Hi, it's Mr. Mac, and in this fourth video in the series of math skills you need, we're looking at areas and perimeters.
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
So here you see a circular oval with a white picket fence all the way around. The distance of that fence is its perimeter, or we sometimes say circumference if we're dealing with a circle. And if you can imagine sitting on a ride-on mower and mowing all that grass, that's the area within the perimeter. What we learn to do is calculate perimeters and areas of various shapes. We'll be able to use formulae to evaluate triangles, rectangles, parallelograms, trapezia, circles, sectors of circles, and composite shapes. Our first shape is a square. This is a plane figure with 4 equal straight sides and 4 right angles. The perimeter is simply 4 times the length of one side. So P equals 4S. So we write the formula and we substitute S, in this case 12 metres. 4 times 12, 48 metres. And that's the distance around the outside. For the area, it's simply side times side, or S squared. So we write the formula, substitute for S, 12 squared is 144 metres squared. And at this point, just look at the units for perimeter. It's metres because it's a distance. The units for area is metres squared, and we write it with an M and a superscript 2. Our next figure is a rectangle, which is a plane figure with 4 straight sides, unequal adjacent sides, and 4 right angles. The perimeter is simply twice the length plus twice the width, or P equals 2 brackets L plus W, close brackets. So we write the formula and substitute L for 7 and W for 3. 7 plus 3 is 10, 2 times 10 is 20 centimetres. The area is simply length times width, or A equals LW. So the area, replace the L with 7, the width with 3. 7 times 3 is 21 centimetres squared. Our next shape is a triangle. This is a plane figure with 3 straight sides and 3 angles, tri meaning 3. The perimeter is simply adding up the distances on the outside for each side. So the perimeter equals S1 plus S2 plus S3. In this case, 6 plus 5 plus 5, which is 16 centimetres. The area is half times the base times the height. So the area equals a half BH. Substituting the base is 6 and the height is 4, we end up with 12 centimetres squared. Our next shape is a parallelogram. This is a 4-sided plane figure with opposite sides being both parallel and equal in length. So the left-hand side is 5 centimetres, so is the right-hand side. The base is 7 centimetres, so is the top 7 centimetres. To find the perimeter then, we simply go twice the short side plus the long side. So P equals 2 brackets A plus B. In this case, replace the A with 5, B with 7. 5 plus 7 is 12. Twice 12 is 24 centimetres. For the area, it's simply base times height. And we're given the height in this question. So A equals BH, the base is 7, the height is 4, 7 4s are 28 centimetres squared. Our next shape is a trapezium. This is a 4-sided plane figure with only one pair of opposite sides parallel. So if you look at this figure, it looks similar size and shape to our previous question, but it's a completely different shape. And so we have a different formula for this. To find the perimeter, we simply add up all of the sides. So P equals A plus B plus C plus D. And so we substitute, starting with 4.5 plus 7 plus 5 plus 5.5 going clockwise. That equals 22 centimetres. The area of a trapezium is a little bit more complicated. We have to go half times the height times brackets A plus B, where A plus B are the two parallel sides. So the area of this trapezium is h on 2 brackets A plus B. So when we substitute A with 5.5 and B with 7, we end up with 5.5 plus 7 is 12.5. 4 on 2 is 2. 2 times 12.5 is 25 centimetres squared. Let's deal with a circle. The oval that we saw right at the beginning was a circle. This is a round plane figure with a circumference consisting of points that are equidistant from the centre. The circumference is simply pi times the diameter. The diameter is the dashed line that goes all the way through from one side to the other, passing through the centre of the circle. So the circumference of a circle is pi d. But you may also notice that the diameter is twice the radius. So the circumference of a circle could also be written as 2 pi r. In this case, we've got a radius of 3. So let's replace 2 times pi times 3. And when we calculate that, and we need a calculator to do that, we end up with 18.8 centimetres, and I've rounded that to 1 decimal place. And just remember to make sure that the equal signs do not lie. So if you do round, if you do make it correct to 1 decimal place, then you have to state that. For the area of a circle, it's pi times the radius squared, or pi r squared. In this case, pi, we know, r is 3, substitute and calculate, and we end up with 28.3 centimetres squared from our calculator, rounded to 1 decimal place. Well, let's see what happens if we have a sector. A sector is a plane figure enclosed by 2 radii of a circle or ellipse and the arc between them. In this case, I've used the same circle with a radius of 3, but this time we're only interested in the pie-shaped sector, which is shaded. And the formula for this is similar, but we need to be thinking of the distance around the outside of the sector. So you can see 2 pi r in this formula, but it's a proportion. To find the curved sector, we take the angle of the sector and divide it by 360 degrees, because we know there's 360 degrees in a circle. And then we multiply it by 2 pi r. So we're finding a fraction of the circumference. But we also need to add on 3 and 3 in this case. In other words, we need to add on 2 radii to get the distance around the sector. Imagine we have a field that is a sector shape and we're putting a fence around it. So the circumference of a sector, or the perimeter of a sector, is theta, where theta is that angle, over 360 degrees, times 2 pi r, then plus 2r. So in this case, we're substituting, or measure the angle, and when we measure the angle, we can see it's 40 degrees. We can use a protractor. We don't need the protractor anymore after this, but you can see I've substituted in 40 degrees. So 40 over 360 degrees times 2 times pi times 3 plus 2 times 3. And you can do that all on the calculator, and you end up with 8.1 centimetres, correct to 1 decimal place. Well, the area is similar. You find the proportion of the area of the circle by substituting in the angle over 360 degrees. So 40 over 360 degrees times pi times 3 squared. And in this case, we end up with 3.1 centimetres squared, correct to 1 decimal place. So those are basic shapes. let's see what happens when we start putting things together. Let's now have a look at the area of the inner field inside the athletics track. There are very strict rules about athletics tracks, so that they are all the same across the country. Each has a radius of 36.5 metres, joined by two straight lines which are each 84.39 metres in length. And usually there are 6 or 8 lanes for runners around the outside, each having a width of 1.22 metres. The question we have is to find the area of what is shaded green. And firstly, this is what we've been given in the question. R equals 36.5 metres. L, the length, is 84.39 metres. And you can see here we've got a semicircle on the left, a rectangle in the middle, and a semicircle on the right. With composite shapes like this, we need to make sure we can divide up the area into plane figures that we can easily calculate. So the width of the rectangle is also the diameter of the circle, which is also twice the radius. And we're given the radius, so 2 times 36.5 is 73 metres. So those red broken lines are 73 metres long. We now have the information we need. The area of the rectangle in the middle is LW, 84.39 times 73, which is 6,160.47 metres squared. Use a calculator to find that. The area of a circle, now we've got a half circle on the left, a half circle on the right. If you put them together, you make a whole circle. So we don't need to do any trickery here, just simply find the area of the whole circle, which is pi r squared. Substituting for r, we have pi times 36.5 squared, and again on the calculator, we end up with a number which is 4,185.4 metres squared, correct to 1 decimal place. Now to find the total area, we simply add those together. So it's the 6,160 plus the 4,185, and of course we use a calculator. You can see there the answer that I've found is 10,345.9 metres squared, correct to 1 decimal place. Of course we don't write out all those decimal places because we know that pi is irrational. It keeps on going infinitely. So in practical questions, we always round when we have pi. Well, let's have a look at another example. So let's find the area of this front wall of the metal shed. You can see that it's corrugated steel, it's colour bonded, and it's a composite shape. It's not one of the plane figures that we've seen. So what we do in this case is we get a tape measure, measure the height, 2.4 metres, measure the height to the apex, that's the point at the top, as 2.66 metres, measure along the front, 3 metres, measure the width of the opening of the garage, which is 2.56 metres, measure the height of that opening, which is 2.18 metres, and then we've got all that we need to calculate the area of that corrugated metal. And you can see if I put a broken line there, a dashed line, it breaks up into 2 shapes, and the top is a triangle. Quite a skinny triangle. And we can see the base is 3 metres. It's the same distance as the distance along the front. The height is 2.66 minus the 2.40, which is 0.26 metres. To find the area of that triangle, it's a half BH. So it's a half times 3, the base, times 0.26, the height, which is 0.39 metres squared. We then want to find the area of this rectangle, which is length is 3 metres, the width is 2.4 metres, and the area is LW, 3 times 2.4, which is 7.2 metres squared. So here's the rectangle shaded in. We also want to find the area of the garage opening and cut it out. So the area that we want to cut out, I've put as black there. Again, it's a rectangle, so it's LW, is 2.56 in length and 2.18 is its height, or the width of that rectangle. And multiplying those is 5.5808 metres squared. So what do we do with those three areas that we found? Well, here they are. The 0.39 metres squared, 7.2 metres squared, and the 5.5808 metres squared. Well, we want to add the two shapes and take away the opening. So it's 0.39 plus 7.2 minus 5.5808, which is 2.0092 metres squared. And we could take those measurements to our builder or to the factory and say, this is the area that we want for the front, and we could do similar calculations for both sides, the back and the roof, and find out how much of this corrugated steel that we actually need. So we've seen how to calculate perimeters of simple geometric shapes and a circumference of a circle. We've also seen how to calculate the areas of simple geometric shapes and more complex areas. In our next video, we'll be looking at solving complex equations. I'm Mr. Mac. Thanks for watching.